Example 3. Find, you're giving z and w. Okay, so find when z multiplied to w and when z is divisible by w. Leave your answers in polar form. So A, it's already in polar form, so I don't have to do anything special except that we will multiply first. So in multiplication, okay, let me remind you of what we do when we multiply. When we are multiplying, we multiply the radius and we add the angles. Okay. When we divide the radius and we subtract the angles. So keep that in mind when we're working these out. So multiply first. So that means I'm going to take my 2 radii, so 4 times 2, okay. Then I'm going to add my angle, so cosine of 3 pi over 8 plus 9 pi over 16. So that's the 2 angles adding together. Plus I times sine of 3 pi over 8 plus 9 pi over 16. And from here, I would just sit here and simplify. So let's work it out. If they give you radians in the original problem, then keep it as radians in the original problem, okay? So common denominator tells me that this is a 16. So this would turn into 6 pi. So 16 and 6 pi. So my final answer when I multiply is 8, okay? Then cosine 6 pi plus 9 pi is now what? So is that 15 pi over 16 pi? Okay, very good. Then plus I times sine of the same exact angle. Okay, so that is what we do when we multiply. Okay, so the formula seemed, when we were reading the formula in class, it sounded really scary, but when you are really working it out, it isn't that scary. Now, what do I do when we divide? So just like a minute ago, we will take the 2 radii and we divide them, okay? And we are now going to attempt to subtract your angles. So take the first angle, subtract the second angle, okay? So same thing on this side. First angle, 3 pi over 8, subtract 9 pi over 16. Yes, I would now need to go and find common denominator. Since we did the multiplication above, this one should stay the same, right? It's still at 6 pi. So here we go. All right, so when we divide z over w, final answer is 2 in the front. So now your radius is 2. 6 minus 9 pi over 16 is now cosine of negative 3 pi over 16. We will talk about that in just a second. Plus I sine of what you get on the first angle, you're going to get on the second angle. Okay, so here's the negative angle. Now in your book, it really doesn't like negative angles because I believe when we define this, it says that theta, radius always has to be positive and theta always has to be from 0 to 2 pi or 0 to 360 depending on if you're in degrees or not. So what we need to do is convert negative 3 pi to 16 in positive angles, okay? So final answer is z divided by w equals 2 times cosine of. Now how do I convert negative 3 pi over 16 to positive angle? What would you do? Let me draw it out for you so you have an idea what negative 3 pi over 16 is, okay? So here's a negative pi over 2. In common denominator of 16, this is really negative 8 pi over 16. So negative 3 is just right there, that very small amount, okay? Oops. So here's negative 3 pi over 16. Because we define it as a positive angle, here's what we need, okay? So would you agree that I can take my negative angle and add a positive 2 pi, okay? Positive 2 pi then leaves me to believe, let me get a different color pen really quick, that I can make a common denominator of 16. So if that's 32, okay, 32 pi. So negative 3 pi plus 32 pi, now you are at a positive 29 pi over 16. Okay. And that's how you convert all of that to positive angle. So now with positive angles and positive radius, okay, the division of z divided by w is 2 times cosine 29 pi over 16 plus I times 29 over 16. So that is for that one. Now, what if they give you a problem, but that's not in polar form? Then guess what? You had to do a little bit more work, okay? I first had to convert it in polar form. So to convert it in polar form, I would need to find r and theta, okay? So let's find r for z. So for z, r is square root of x squared plus y squared, okay? X squared is 1. 1 squared is 1. Y is -1, but -1 squared, it's also 1. So radius is 2 for z. I'm sorry, rad 2. Then I also need to find theta. So theta for z is tangent inverse of y divided by x. Let's sketch out where z is. Okay, so I want to make sure if I need to add a pi or in degrees, 180 or not. X is positive, so I'm positive, and then z is going to be, I'm sorry, y is negative. So you're in quadrant 4. Okay, so theta in quad 4, I can totally handle that. Okay, y is -1, x is 1, so this is a multiple of 45 degrees. Okay, if you punch this in your calculator is going to give you a -45 degrees, but you can't have a -45 degrees because theta is restricted from 0 to 360. So I would now have to use 315 degrees. Okay, so that's theta, and that is r. So now let's put it in polar form for z. So z is square root of 2, okay, times cosine of 315 degrees plus I times sine of 315 degrees. No, we have not done multiplication yet. We're just converting to polar. I will now try to graph out w to see what quadrant that is in. X is positive, y is negative again. So again, I'm in quadrant number 4. The reason I do that is because I want to make sure if I need to add, when I'm looking, add 180 degrees or not when I'm looking for theta. So w equals, let's find radius, okay? So r equals square root of x squared plus y squared. X is 1, so 1 squared is 1. Y is negative rad 3. Negative rad 3 squared is 3. So this is going to give me square root of 4. Square root of 4 is 2. So the radius for w is 2. I will now attempt to find theta. Okay, so theta, it's always tangent inverse of y divided by x. So tangent inverse of y is negative rad 3, x is 1. We're in quad number 4. This, if you put in your calculator, okay, let me give you, it would totally give you a negative answer. Yes, it will give you a -60. But we can't have a negative angle for theta. So we're going to go the other way around. Oops. -60 is equivalent to 300 degrees in the positive rotation. So w equals 2 cosine of 300 degrees plus I sine of 300 degrees. Okay, so that's just what z and w converted to. So now I will attempt to find multiplication of z times w. To do that, I will multiply the radii. Okay, the radius with radii is really the correct term. So rad 2 times 2 is 2 rad 2. In multiplication, I will add my angles. So cosine of 315 plus 300 and plus I sine, same thing, 315 plus 300. Now because this problem did not start out in radians, so most of the time when it doesn't start out in radians, you can just put it in degrees, okay? But if it starts out in radians, then you keep it as radians. So final answer, when I combine these, it's going to be 2 rad 2, okay, times cosine of, okay, well, 315 plus 300 is now 615 degrees. And we are going to talk about, we can't keep that at 615. Sine of 615 over here as well. 615 is over a revolution, but theta, remember, theta was restricted to just the first revolution. So at 315, I can subtract it from a full revolution. Okay, so side work. 615 I meant, not 315. 615, okay, it's the angle we have. Take away a full revolution. So you should end up at 225? 255. Okay, there you go. So let me confirm really quickly. 615 minus 360. 225. Okay, so this is now at 255. I am sorry, 255. Okay, so 615. Okay, take away a revolution. It's the same location as 255 degrees. So that's what we would use instead of 615. And yes, you do have to bring it back to the first revolution. Okay. So 255 degrees here as well. So that is the answer if we were to multiply them. Okay. Now let's do division. Woohoo. Okay. So z divided by w equals, so z has a radius of radical 2. Okay. W has a radius of 2. I will now try to subtract the angles. So cosine of 315, take away 300 is now just cosine of 15 degrees. If you have cosine of 15 degrees there, you will also have cosine of 15 degrees here. And I am done with my division problem.